You're listening to JS Party, the award-winning weekly celebration of JavaScript and the web.
Hear ye, hear ye!
Our new weekly podcast plus email newsletter covers all the developer news that's worth your attention. We keep it brief, entertaining, and always on point. Check out Changelog News at changelog.com/news.
Help me help you.
Thanks to our partners at Fastly for shipping JS Party all around the world to wherever you listen. And to Fly.io. Host your app close to your users. No ops required. Okay, hey, it's party time, y'all.
Hoy hoy! Welcome to another exciting JS Party. I'm your host this week, Nick Nisi. Ahoy hoy! And I am here to do an ORMazing show with KBall. KBall, how's it going?
I do not have a pun planned ahead to one-up you there, so I'm going to let you win that. But I'm excited. I like ORMs. I think there's a lot of interesting conversations right now about interfacing with SQL, especially I've been playing around with using AI to talk to SQL and things like that. So I think we have some opportunity for conversations about what are the right levels of abstraction to talk with our data. So looking forward to it.
Yeah, I like that. And because I can barely spell ORM, we do have a guest to help us out with that as well. And he is the creator of Joist ORM, Stephen Haberman. Stephen, how's it going?
Yo, I'm doing fine. Yeah. Thanks for having me.
Awesome. Tell us about yourself.
Sure. I'm a software engineer. Been doing this for a little while. And I don't know. Got started back in the day doing Java, back in Java. I don't, maybe that's going to...
We won't hold it against you. It's okay.
Oh, don't hold it against me. But I actually did quite a bit of that for a little while and enjoyed it. And about 4 or 5 years ago, found this little thing called TypeScript and was just really surprised, love the type system. And, back in the day, seeing people do Node in, circa 2010 with the only thing you had was callbacks was just like, you guys are crazy. But like just, the JavaScript language and TypeScript on top of it has grown so much, with the evolution of async await and just everything that they've grown in the language has been really impressive. And so I've been doing that lately and really enjoy it.
Did you hear that, Jared? Did you hear all of that praise for TypeScript?
Ha!
Not listening. Not listening.
That's right. It used to be you were trying to convince me, but I'm a convert for the last couple of years. So Jared might be the one person who's regular on the show who is still a holdout.
Yeah. Well, that's fair. I mean, to a lot of what TypeScript has been able to do, for sure, is on top of the core evolution of just JavaScript itself. All of the async await stuff in the core languages has certainly benefited TypeScript a lot. They've got a lot from that.
Now, you're joining us to talk about ORMs. So maybe it'd be appropriate to start with a definition of what that is.
Sure. Yeah. I mean, there's it's object relational mapper. So it's basically that you've got a relational database floating around that you'd like to talk to as ergonomically as possible. Kind of the OG way of doing that is raw SQL strings. Like every time you want to talk to your database, do SQL, select star from this and this and this. Actually, I'm pretty. We can get into the pros and cons of ORMs later, but for the more esoteric SQL that you do, I'm a big fan of doing custom SQL when you need to. But for the 80 to 90% ratio of your code that is like, I just want this author entity. I just want this book. Well, I'm playing my hand a little bit by saying the word entity, I guess, but I just want this author row or the book rows for this author. I think it can start to get kind of tedious to do SQL selects for every single little boilerplate thing. And so I think that's where ORMs come in. Of some of them, back in the day, you could see ones that tried to do everything. But I think if you stay in the circle of competence of just, treating your database for 80% of things as an object graph and then being able to very, ergonomically get your data out of your relational database. There's also reads, but then also writes, writing back what you've changed. I guess, there's a spectrum of how fancy ORMs go insofar as is it just doing just queries and then also doing the reads and the writes back. But as you go on the spectrum of fancier ORMs, you'll start to see a lot of things where, applying business logic around your writes of, validation rules and lifecycle, even get into some of the reactivity that Joist is bringing to the table and, really leaning in on encapsulating business logic and business rules in a central location. beyond just like, I'm reading and writing data.
Well, can we start then with, since there are so many different directions that ORMs take and different trade-offs that they can make, what inspired you to write a new one?
Yeah, that's a good question. So I think, Joist came around probably circa 2019 or so. And so what the problem that we were solving there at the time was, standing up a new tech stack, a very stereotypical tech stack at the time. We had GraphQL on the back end and React on the front end. And we're using Apollo and Postgre, love Postgre. And yeah, just trying to find, what was the most ergonomic way of standing up our backend. And when looking around for other tools at the time, there's the class of tools out there that like the Hasuras and the Postgraph files that are super ergonomic in terms of, directly mapping your database schema to your GraphQL public API, super amazing. But, kind of touched on that business logic thing. We had been wanting to find a way to, do like 80 to 90% of like just take your database schema and make your GraphQL API out of that and do that for the common case. But there's always this like last 10 to 20% where I think like the Hasuras and the Postgraph files, you can start to miss out on well, I don't want my GraphQL API to exactly be my database schema, right? And so that ruled out those. And just from my past, had done enough ORMs that, I like, or had used ORMs that, I kind of like those. I'd used TypeORM in the past and was just looking to use something else. We started out with MicroORM, which is actually really great. I still like it. It matched, and you can tell like probably 60 to 70% of Joist's API matches Micro because our code base was on Micro for probably 6 to 9 months before we flipped over to Joist. And the big reason for moving away from Micro, there was nothing wrong with it, but we were very much in the GraphQL environment where it's so easy to do N+1s. And so we were really looking for an ORM that would build in data loading, the whole Facebook data loader pattern of like, you wait until the next event tick to kind of like see whatever happened. And then at the end of the event tick, you're like, oh, you asked for 10 authors, like instead in this one event tick, instead of 10 SQL calls, I'm just going to do one SQL call for all 10 authors with a where in. And I actually had a pull request into Micro to kind of start to do that. And it worked, but Micro was just mature enough at the time. It was probably already, I really haven't kept up on it. I liked the Micro author. He was great to work with. But it was probably I'm going to make up V3 or V4. I don't know. It was a little while ago. But already pretty a mature code base. So it just wasn't as easy to wander in and like put data loader into the guts of the ORM after it had already been established and that sort of thing. And so really that was it. That and then the other thing that from my days working on TypeORM, and again, I haven't worked with TypeORM in 4 or 5 years at this point, but the biggest frustration I remember, with disclaimers that I have no idea what it looks like these days, but was that it was incredibly opaque whether your collections were loaded or not, or even any relation. So you might go get an author, and so to go back to like one of the things that ORMs are really good at, is like lazy loading parts of your object graph as your business logic needs them, right? So you might start at an author, your endpoint is like, do something with an author. And so you get the author. And then, you do some business logic and you're like, oh, I need the books. And then you do some business logic and you need some book reviews. And so ORMs are really good about kind of, making it ergonomic to load more and more of your little subgraph as you go. But like the trade-off is that you start out with it not loaded, right? So you start out with an author and like, you don't have the books yet, and you don't have the book reviews. And my recollection of TypeORM was that it didn't have a way of representing these two states in the system, right? And I'm trying to remember, I think you could do things like, for the author in the books, tell it that the books is always loaded, but that would mean like every time you touched an author, you de facto brought back the books. But then at least in the type system, you were guaranteed for the books to have been loaded. But you rarely want that precisely because this kind of lazy loading of the object model is de facto what ORMs are good at. And so tangent back to like why did Joist come around? So the kind of two ahas that kicked off Joist was like, want to build a data loader from day one for every single, lazy loaded call. And the other one was, figuring out a way in the type system to represent the two states of a collection is not loaded until I ask for it to be loaded with a populate hint. Or load hint, which the load hints and populate hints are not novel to Joist. They go back to ActiveRecord, and I'm sure other ones before where you start with an author, but before you go in and play with the guts of the author, you say, by the way, I know I'm going to want the books and the book reviews loaded, and so you give it a little hint up front to like, please go get those for me, and then your business logic after that can can have that. So like you've always had to do that with ORMs, like the active records and type ORMs of the world. What was novel with Joist about the time was that transition changed the types. So like you would start with the author and you couldn't like do books.get. You would have to do books.load, which was a promise. And then for every book, you'd have to like, do my book.reviews.load, and that would be a promise. But if you did, and so it's by default safe, which is one of the things I don't think I liked about type ORM was like by default, like the collections would look like you could call get, but it would turn into a runtime exception if you hadn't made extra sure that you had done a populate hint 10 or 20 lines up, or even a completely separate method, right? Like that's where I think this can really break down. Like I remember even Active Record still kind of has problems with this, where you might have an endpoint that kicks off and like loads an author in Active Record. And then eventually you get into abstractions, like you call this helper method and this helper method and this helper method. And at some point, one of these helper methods is going to need data that like you didn't remember to populate, not only 10 or 20 lines up, but way off in some other method in your endpoint method. Yeah. So anyway, so with Joist, TypeScript map types are just so neat. So I had been playing around with a prototype of like, can I have a domain model that is inherently unloaded? And when I apply, overlay this type hint of like, please, ask the ORM to go load the data, both go load the data from the SQL database, but mark in the type system that all of these are now loaded, and you can do gets. And so anyway, super long tangents, but those are the two that, once I had those figured out, both of those seemed novel enough to like, okay, now it's worth, taking what had been musings and turning them into an actual project. And that's what kicked off Joist.
There's a number of threads there that we could pull on.
Yeah.
I think I want to start first maybe going down the data loader thread. So I'm pretty familiar with the data loader pattern, but I don't know that everyone who's listening to this podcast will be. So can you kind of explain what that pattern is and what it enables?
Yeah, sure. So data loader is just a way of doing automatic batching of almost anything in your system. And so it comes out of Facebook. And maybe the niftiest thing about data loader is it just works on top of raw promises. So I don't know if this is maybe too academic of a tangent, but if you look at the concept of data loading, is not super new. So Facebook has a library called Haxel, Haxl, that builds this concept in Haskell, and that was from 10 or more years ago. And then somebody had written a version of that in Scala. They had kind of ported it to Scala, and I'm going to forget the name of it. There was maybe 2 libraries in Scala that did it. And we had used it about 10 years ago when I was at a Scala shop, but at least in terms of the pattern. So like, I think it's kind of easy to talk about the non-JavaScript version of the patterns. And what those would be is instead of like, directly loading the data, you would make little, I'm going to go ahead and use the word promise because that's what it ends up being in JavaScript, which is why it works so well. But, back in the Scala days, you would say like, well, I'm going to have an author and I'm going to, go, loop over the author's books. And I want this book, this book, this book, this book, this book. But in these old libraries, instead of literally getting the book, you would make a little AST of like a promise to get this book, promise to get the next book, promise to get the next book, promise to get the next book. And you'd kind of have a layer of like your intention to get the data. And then you would ask the runtime system, like the Haskell runtime system or whatever the Scala one is, to like, okay, now please go do that. And it would have the smarts to like, oh, I can see that you're trying to load 10 books, like, but instead of doing, make a bulk wire call, book wire call, book wire call, book wire call, and all of a sudden you have an N+1 of a whole bunch of IO calls, a whole bunch of wire calls. The Haxel and these other libraries would recognize that you're doing essentially the same operation with just for a different where clause, basically, right? And so, can I do one operation, one wire call that, for all 10 books? And the Facebook data loader library, so it does exactly the same thing. The innovation there is that they realized you can use the event loop instead of what in other languages you need some sort of like little kind of interpreter thingy to do, right? Like again, I don't know if this is meandering and kind of technical, but the idea is that sure, if I'm going to take an author and I want to loop over the books, of course you have to be doing something with, I want to load each book. Each of those is going to be a promise, so go to, load book 1, I get a promise, load book 2, get a promise, load book 3, get a promise, load book 4, get a promise. And what data loader lets library authors do is, since the promise has to wait anyway, you don't get the book right away. The promise is like, well, I'll give it to you in a little bit. And what data loader does is it, before it even kicks off the wire call, so you ask for book 1, book 2, book 3, book 4, it doesn't immediately do the wire call, but it puts onto the event loop basically a flush that says like, okay, do this wire call at the end of the event loop, which will come up right away, right? Because the event loop's just going spin, 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 spin. And so it puts a little, basically like a flush event at the end of the event loop that then, when it gets hit, can let the library author or whoever's using data loader realize like, oh, okay, there have been 10 promises that asked for books. Before I actually kick off the wire calls, I'm going to condense those down into one wire call that will load 10 books all at once. And data loaders, it's really a pretty small, it's probably, I don't know, 150 lines of JavaScript, maybe something like that. And could, auto batch anything. It could do it for microservice calls. It could do it for SQL calls. It's really very generic and really awesome how well it fits into the event loop and into JavaScript.
So if I were to kind of replay that back and simplify a little bit, it's taking the concept that any sort of call that goes over the wire, whether it's to a database or an API, that is slow. And it has a sort of intrinsic latency to do that, whether you're fetching one book or, to use your book's example, or 10 books. And so it says, okay, instead of sort of optimistically fetching as soon as you ask for it, I'm going to accumulate the set of requests that you have into an array and wait till the next time that data is requested, or rather the end of the event loop. And now I have a list of things. I'm going to try to condense that list of things into a single query and pull it back. And I think with data loader, you actually define how that condensing happens. So you get a list of keys passed off to a function you define. You say, okay, I have a list of keys. I know how to batch this into a single query, grab that, and then I hand back that list. And so data loader is kind of letting you multiplex a set of queries into a single query that goes over the wire, and then demultiplex that data back out to all the requesters that asked for it.
Yeah, that's a great point, that you have to both combine and then uncombine, because that's also important on the other side of you get back one big batch response of here's all 10 books, but you're like, well, I got to give the first book to the first caller and the second book to the second caller and do that bookkeeping. Yeah, that's a great explanation.
So one thing that leads me down to, that's a question kind of specifically for Joist, is, and this goes back, I think, to how ActiveRecord would do this, right? So ActiveRecord did not have the data loader pattern, but it still would lazy load. And so within a particular kind of query, you could accumulate a set of queries. So you might say, hey, I'm loading a bunch of authors, and for each of them, I want their books, and each of whatever. And then like at the end, when you actually go to load that data, that's when it, issues that query. And it tried to do something smart where sometimes it would issue a set of queries and sometimes it would issue a single query with joins. Where I have seen data loader used in the past, it was usually accumulating on a per table basis. It was not trying to do any of that joining. But I'm curious, with Joist, you have potentially more of a global view or a global way of hooking this in. Are you able to accumulate queries across tables?
Yeah. Oh, well, actually, we could. We don't right now. We could in some cases. So in the case, you don't always know what the next level of table you would need is, right? It depends on whether you give it an explicit populate hint. So like one of the great things I think about Joist is that you don't actually need to use populate hints. So as far as I understand with Rails in your example, if you knew your business logic was going to I have an author and I'm going to go through all the books and I'm going through all the reviews. If you wanted to make that, and you're saying you could either make one giant query to join in all three levels of data, or you could do one query per level.
Exactly.
So what the neat thing with Joist is I'll go to maybe why we don't do that right now is that with Joist you don't even need that upfront populate hint. So because a data loader, you can just say load the author and then you'll load.
You can accumulate all the levels asynchronously.
Right. And so if you do that, we don't know what you're going to need ahead of time, right? Until after we've loaded all the books, and then you go on and you're like, oh, I also need the book reviews. And you're like, oh, you also need the book reviews. We'll get those for you. And so if you're not using these ahead of time populate hints, that the populate hints would tell us ahead of time that we need ahead of time multiple levels of data. So if you're not using that, then no, we couldn't. But if you do use that, we could technically. We don't right now for no real reason two reasons. One, just haven't gotten to it yet. But the other reason is that, to go back to that kind of the her-surs of the world that exactly match the domain model, or, take the database schema and exactly map it out to your GraphQL API. Joist also, wants to do that for 80% of things, but there's this other 20% of things that are in your domain model that are not necessarily strictly in the database, so derived properties and calculations that you might just want to do in memory. And for the most part in Joist, those look the same, in kind of a good way. If you're consuming a domain model, you can't always tell which collections are literally from the database and literally from, or more of a derived value. And it just ended up being easier for our initial implementation of the popular logic to not have to subdivide those, because to do the join thing, you really have to be getting everything literally from the database to get it into a join. And we could go back and implement that, but we'd have to like split the populate hint into like, okay, here's this half of the populate hint is stuff that was literally coming from the database. And this other part of the populate hint is coming from derived collections and derived fields that we can't literally put in the join.
Interesting. So if I understand correctly, you're kind of allowing someone to do a JavaScript level sort of derived view or computed feature of some sort. And at the Joist level, you actually are able to treat those pretty much the same way.
Yeah, like a lot of the ActiveRecord things, like it has many through. We have terms that kind of come from ActiveRecord, but they don't map one-to-one. So I'm forgetting if I'm saying the Joist one or the ActiveRecord one, but has many through, or has one derived, has many derived, and these sort of things. Little like abstractions that are super commonly used in your domain model that are little shortcuts, almost like Rails scopes. I haven't done a lot with Rails scopes. Actually, I haven't done a lot with Rails. I worked in Rails for maybe 6 months. Circa 2008 or something like this, and then was in a shop that was moving off of a Rails monolith onto other things. And so haven't done a lot in it, but did enough to be like, oh, wow, this is nice. Like just the ergonomics of Rails is the
ergonomics of ActiveRecord are, as far as I've seen, unparalleled. It is
totally agree.
Really powerful.
And so I've done just enough to know that, I want to, I come back to like Ruby that, at least in the past, didn't have types. I'm enough of a static typing bigot that I like to play in the languages that have types. But for sure, 100% use ActiveRecord as an inspiration for, gold standard.
Another direction I'd like to dig into a little bit was this piece you were talking about sort of the being able to check with the types whether something is preloaded or not. Mm-hmm. And I guess a part of me is wondering why you need it. And here's let me flesh that out a little bit more. One of the benefits of going to a fully asynchronous model, which is what you need to do to be able to take advantage of data loader, is that I, as a caller, don't need to know whether you've loaded that data or not. I treat it the same way because my code is already having to be asynchronous. I'm already having to treat it as if it might come back sometime undetermined in the future. I already have to await it if I need it now. So why do I need a type hint to say this is preloaded versus not? I can treat it the same regardless.
Yeah, no, that's a great question. I think it's just that async programming can be pretty tedious once you get down to like, it's great for this sort of dynamic discovery sort of thing where your system kind of, at least the data loading side of that, kind of evolves or whatnot. But I think the best example I can think of is like Nick from the talk a week or two ago. Like if you just look at, I'm going to have a book and I'm going to go over I have an author and I'm going to go over the books, and you do books.load, like, okay, there's an await. And that's not too bad. But now you're going to have to do .map, and now each of your book.reviews.load is going to be a promise. And like all of a sudden, once you've got like for loops and maps and filters that are doing asyncs, starts to get kind of ugly. So when you've got like, I've got 10 lines of business logic that I want to write right here in scope, but it's like 2 or 3 levels deep, and I'm going to await promise all and, do an async map or an async filter for every single little operation. It just gets super tedious. And I think I don't have any examples at hand, but I like to show off the before and after of like, yeah, sure. Here's how you can do it with, a bunch of .loads, .awaits, and all of these other sort of things. But if you do the preload hint where now it's just like .gets and it's all synchronous, you can do like flat maps and all filters and all sorts of things, just like the, your regular collections, your regular lists and maps as if they're in memory, and all of a sudden code that is like gnarly and just goes to like literally 2 or 3 lines of functional programming. I think it's a huge night and day difference.
That makes sense. Well, and it makes me wonder if there's room for a utility that basically does that, even in a non-preloaded case, where it says, I've got all this data. It might be loaded, might not be loaded. I want to flatten it out into synchronous so that I can just work with it.
That sounds a lot like what Joist does. Yeah. Granted, it's super baked into an ORM, right? So if you're using is like kind of like how generic data loader is, could you do the same thing for, to go back to your question of like why we don't do the SQL loads for joining, 3 levels of data, which I do want to do someday. But it is actually pretty generic. Like right now, the Joist code that does this little like preloading thing like in a good way, is pretty agnostic about that it's asking SQL to be executed. It's, it just sees them as promises that then anyway.
It does seem like, it feels like an interesting problem to even make that aggregation into a join work potentially in the async case, right? Because if you could, having Joist as a sort of central pivot point for data loader, you could write a single data loader function that is receiving all of your different classes of loads and aggregating, and it could distribute them out into distinct underlying fetches, or it could say, hey, you know what? All of these things are connected. I can join them because I know the relationships between the parts of the objects.
Yeah, I hadn't thought of it that way in terms of doing it. Yeah, I think I was leaning, when I thought of how we would implement it in Joist, I was leaning more into like, well, we've got the populate hint, and we would lean into the populate hint to know, ahead of time what we would need to do. While you're loading books, like, oh, I'm going to need book reviews. That might be where it may not work without the populate hints. Is like, unless you've got a hint explicitly telling you it's going to want the next level of data, the runtime doesn't actually know yet. Like nobody has called book review.load. So like the data loaders wouldn't have been primed to know that they need that yet.
Mm-hmm. Oh, because you have to load the original author or book level before you have an object that you can call that loader on.
Yeah, 100%.
Yeah, and if you wanted to get around that, you'd have to fake out promises, and then it gets really complex. Like I could imagine returning a customized thing that wraps a promise, right? That is like, this is a book promise, and I can call on it to load, book reviews, and it knows now to aggregate things. But that's probably more complexity than is worth it.
Yeah, you're like speculatively executing the next layer of business logic, I guess, to see what it's going to ask for. Something like that.
That's kind of what I was thinking. It's kind of extrapolating down the data loader pattern of not fetching the data until the absolute moment you actually finally need a piece of data. And when you have the structure of the tables, which you do, you understand the structure of the relationships here. Theoretically, I don't need to load the data on a book to understand how to load the associated book reviews. And so once again, in theory, you could create this like I don't know whether to call it beautiful or ridiculous, but like this crazy structure that is keeping track of, okay, here's a thing that's going to represent, it's back to your point, like this is going to represent a book. It doesn't yet, but you can expose these operations on it, which will then, follow down the relationships and do the correct joining and all of that mess. I don't know that it's worth it at all, but it's that's where my head got to.
Yeah, I think the trick there would be like, I would imagine that the logic that you would execute on the pseudo book would expect it to look and smell so much like a book. Like it would want to do like, is your title this, or is your, is your interacted in a way that, you could return a fake book, a null book that just return, empty titles and that sort of thing. But since you're executing actual user business logic code against it, it seems like it could pretty easily trip up potentially.
Yeah.
So.
I think the moment that you have to actually access data, now you've got to issue your queries and load. But you could, in theory, delay, and once again, I don't know how much this would show up, but you could, in theory, delay up until that point, and maybe by then you've also told the system, hey, I want the reviews and I want these other things. I don't know that it's worth it, but I just seemed like an interesting direction. I'd love to see the experimentation with data loader, because I feel like asynchronous data access patterns that are easy to use are an innovation that has happened, but are not widely spread. And so, kind of exploring what those possibilities look like is fun.
Yeah, I agree.
Nick, I've been talking a lot and you're sort of sitting there nodding. What's on your mind? What are you thinking?
Mostly trying to keep up, I think. I think you answered the question that I had coming up about like that example you had with like, loading books and then loading reviews for the book. And I'm just curious how that looks from like a type perspective. Would you, when you call load on the books, would you get that data, but then the reviews is like a promise that will resolve to that data, or an object that you have to call load on again? How does it work in Joist?
Well, so in the vanilla case, which is like not using, preload hints, you would say, I've got a book and I'm going to go to the reviews and I'll load the reviews. That's a promise. That gets you the book reviews back. You might have, and they just look like objects now. And so that's kind of pretty vanilla. Now, I guess we kind of already started a second layer down in the graph, because, now let's say book reviews have comments, right? And so if you had books and you load a bunch of book reviews, to access the promise, to access a book review's comments is going to look like a promise because, we're not using any of the preload hints. And so to Joist, it's just a book review. There's nothing that has told Joist to load the comments ahead of time. And so you would go into bookreview1.comments.load, do an await, bookreview2.comments.load, do a await and that sort of thing. But if you had, done a thing where book, I want you to populate your book reviews, and I'm going to pass a little hash of populate the book reviews and their comments, a little nested hash of book reviews, comments. That's going to change the type of your book itself. Granted, you do technically have to have a new variable for that because, maybe although when you do, if you know this ahead of time, you can do const b is, load this book for this primary key and then pass your populate hint here as the third argument to load. And then your b parameter will already be, it'll have the type overlaid with it. So, there's just the normal book type that knows that, knows book has a title and it has comments but the normal one, you have to load the comments. When you do this as a promise, when you do this past the, books as comments, you basically get a type overlaid on top of this, which all it does is add .get methods to the collection or to the relations. So if you've told it that you want the comments, now when you do book.reviews, actually, since you've told it you want reviews and comments, you could now do, book.reviews.get. And so you do book.reviews.get, no promise, sub 0, it's just a regular array. And you could do comments, and then you could do it. And so now this comments is no longer just comments would be a one-to-many with a load, but we've added the get overlaid on top of the type that we've added the get method to the comments property, so now instead of doing comments.load and awaiting that, you can do comments.get.length or whatever. And so it's added a bunch of getters that are synchronous into what would otherwise be relations that you have to load and wait for. I don't know if that was maybe what you were asking.
Yeah, I think so.
So the relations themselves are an object. And to access the underlying array, if it's a one-to-many or something like that, you use either .get or .load on await.
Right, which I think has thrown some people off ergonomically with Joist. Like they would expect if I take a book and I've got the book reviews, they want the book reviews to be literally an array of book reviews. And to your point, no, it's not actually that. For a book and book reviews, it's a we call it a property, but it's a holder of them that doesn't have them yet, right? Because, or maybe it does, right? If it doesn't have them yet, you have to call .load,
right?
So
but that lets you abstract around that.
Yeah, it lets us change the type because if we couldn't do that, it becomes hard to book.book reviews sometimes be just an array because it's in memory, but sometimes it's a promise of an array when it's not. And by making it a property, and it is, once you get used to it, I sort of super just blends into the background. But you do have to do .load if it's not in memory and .get if it is, and then it's just as if it's a regular array.
So if it's not in memory, can you do .get and it will forcibly run the async under, basically force you to wait there? No, right. So that's no, it'll blow up and say you can't do that. And the assertion is that that will be a compiler. You're never allowed to call .get in a way that would blow up at runtime because it's without it being a compiler where the type system knows it's not loaded. Got it. So it forces you to be explicit about when the data is going to be loaded.
Exactly.
And not sort of accidentally force synchronization when you don't want it.
Right. Yeah, which works out really well. It's this sort of thing. The thing I love the most about it is that is orthogonal to the n+1 prevention. So I think in a lot of ORMs, this whole thing of populating so you can do the .get is super ergonomic, which is great, but you have to do that to get n+1 prevention. You have to tell the ORM up front that you want 3 levels of things. But with Joist, you can still do that. You can still use populate hence to get .gets and use it in memory, and that's super great. But you don't have to. If your business logic is scattered over multiple functions that get called in a loop and all of these other sort of things, it's still going to d n+1.
Right, because if you don't do the populate, then you're forced to program it in async style, but that moves you into data loader land, which can do that aggregation for you, and you're golden regardless. That's beautiful. I like that. So that container package where the relation is actually an object wrapping it, is that the same when you're doing like a one-to-one relationship?
We have different implementations of those. So we call our term is just it's a relation anytime you point to another entity or collection of entities. And so you can have like two categories of relations, like some point to a single entity, which is a reference to another entity, and others are collections to other entities. And on the point to one side, you've got either a one-to-many, which is just the foreign key, or a one-to-one, which is an incoming foreign key. And then on the collection side, you can have one-to-manys or many-to-manys. And so, yeah, we have 4 or 5 implementations of each of those things that know how to have get methods if it's in memory, and if it's not, you call load, and then they each have their own data loader implementation that, because to batch many-to-manys is slightly different than batching one-to-ones, is slightly different than batching each of these. And so they each have their own data loader implementation that will do the N+1 prevention.
Cool.
Do you find yourself itching to grow at work, but you're not getting the support you need from your manager? Or maybe you're at a career transition and trying to figure out what you want and how to get it. Or you've got a great job, but could use an external perspective on some tricky cross-functional relationships. Hi, this is KBall from JS Party, and these are the exact types of problems I'm helping folks with in my new business. I think about it as pair programming for non-technical problems. If you're curious, you can learn more and sign up for a free exploratory session at kball.llc/coaching.
Talk now a little bit about how you enable putting business logic in. And I thought it was interesting looking at what Joist does compared to ActiveRecord, where you want your ORM to be able to keep up with data migrations, right? Table changes, things like that. And in the ActiveRecord world, this is all done magically behind the scenes. You don't see it. Whereas if I was understanding it correctly in Joist, you actually have a sort of generated class that is visible that presumably I don't touch because you're going to be modifying that to keep up with data. And then you have another class that is where I can put my custom logic. Is that right?
Yeah, 100%. So
I was going to say that might relate to a question I had, which was how you define those relationships.
Yeah, we can cover both. So the relationships, at least all of the ones that we've talked about, are defined just their foreign keys. And so Joist will look at your database schema, and which is also what ActiveRecord does. We'll get to KBall, your point. But so we have a code gen step where we look at the database and all of the tables and pull in, foreign keys and figure out pointers and those sort of things. And then, we generate there's 2 files. So there's an author.ts, which we will create once and then never again. So it's safe for you to put stuff in there. But that author.ts extends an author code gen, which has all of the super mirroring your database of getters and setters for first name, getters and setters for last name, getters, but also for these relations of that's where an author cogen is where we know books is a one-to-many, but publisher, author has a publisher, so that's a many-to-one, and just all of those things go in this author cogen class, which I think we can check it in actually, but it's generated code. You're not supposed to touch it, so you don't have to. And just like every time you run your database migrations, you run your migrations, and then you run the code gen step, which makes these author code gen and book code gen and book review code gen exactly match your database schema. You mentioned ActiveRecord. That's actually extremely similar to what ActiveRecord does. It's just that we do it as an explicit code gen step, and they do it when your Ruby process boots.
Right. Yeah, they're doing it at runtime, and I never see that code.
Yes, right. And we do it at CodeGen time solely. Well, there is, a slight assertion that if you change your migration once and then you're going to run your test loop 50 times, moving that scanning of the schema and all of that stuff, to happen only once, kind of would amortize the cost potentially. But the biggest reason we do it is just so the TypeScript can see it.
That's what I was going to guess, right? You get types available to a compiler. They do not.
Yes, 100%. That's 95% of why we do it. But yeah, and so just to follow on that a little bit, the author code gen always exactly matches the database, but the author, to go back to ActiveRecord in 2008, when you pop open in ActiveRecord view class author and that is it. Versus all of the Java Hibernate, whatever annotations and gyrations you have to do compared to the day, it's just it's magical. And so that's what Joist provides, tries to mimic. But then that author TS, it gives you a place to add business logic. It lets you add other getters and setters that are built on top of the other ones, or other has relations that are built on top of the other ones, or validation rules, or lifecycle hooks, and all of the real meat of your domain model, separate from the boilerplate of what my getters and setters are.
Can you quickly go into what are the life cycle hooks that you expose and how they interact with your validations and other pieces?
Yeah, sure. So we'll see if I think we only have 3 or 4. So we have before flush. We should start with before create and before update. So before create only runs on creates. Before update only runs on updates. Before flush runs on either. So maybe you have business logic that wants to run on either create or update. And then we have before delete. And then I think we've got like a after committed, which the idea there was like, okay, after I commit, I want to make a wire call to another system, but like I need my primary key to be set first before I make a wire call. Some of these things we don't use after committed very often, but I think we've got that. And there might be one other one, but really like the meat and potatoes is before update, before create, and before flush. And we also have validation rules. And the difference there is that so the lifecycle hooks can have side effects, like you're allowed to, in an author before create, be like, oh, fuck, I want a book by default, or something like this. You're allowed to, or you can tell that I already have some books, but I need to auto-publish them, or I don't know, whatever your business logic is. But then in the validation rules, those don't have side effects. And so then the way that our, so we use a unit of work pattern, which also throws people off a little bit, like it's a little bit different, which actually that is where we depart from, just being a active record clone. Is in active record, you'll do things of like, author.save, and it literally does the SQL there, right? Or author.update, and it literally does the SQL there. We kind of like, to the point of data loader, we want to wait a little bit anyway. But also we use this unit of work pattern. It's called entity manager. Again, kudos micro, because that's what it was called in micro. But it's basically a per request cache of data you've already got from the system. So if you go back to the old days of the hibernates and these sort of things, like caching was a really big thing, but they would do like caching like at the machine level or the process level, and all of a sudden you have to worry about staleness and all of these other sort of things, and that's just too hard for me to really be excited about. And so Joist right now doesn't do any sort of process sort of cache. It just does it per request, which is usually pretty safe. Like for this request, have I already got this author? And if you have, like, any changes that you would have made to it would be in your little memory. So, so anyway, why was I talking about the entity manager? So
do you delay flushes until after you respond to the user?
Yes, right. So you start.
That's brilliant.
You start your. So it's not like it doesn't live across requests, right? But I'm in my save author mutation or endpoint. You're going to start it. You're going to make an entity manager for this request, and then do a bunch of stuff. You're going to load some authors. You're going to load some books. And you're going to mutate some authors, and you're going to mutate some books in memory just by touching the objects. And then when you do em flush, it's like, oh, let me go diff whatever you've changed in your domain objects and figure out like, oh, I should like save all of the authors. The really neat thing there is like if you've touched 10 authors, it'll batch those into a save. So it batches saves and updates, just like it does loads.
That is a very nice improvement.
Yeah, right. I was talking to a friend the other day who was like, this entity manager thing was a little weird, but then like, the first time I went to like think about like, oh yeah, I don't want to have 100 little different inserts. I was like, oh wow, that turns out that was nice. But the other thing that em flush does is run our hooks and our validation. So it technically runs the hooks first, because since the hooks can run side effects, there might be other entities that it needs to then hook, right? Like if you had an author and its hook, touched a book, well, okay, now I need to loop back around and like do I don't want to do the author hooks ever again, because then you could like, infinite loop, but I'll at least do the book hooks again. And so there's this kind of, stepwise function where you handle like running hooks on anything that might have been loaded by your other hooks. But then once all of that is done, then you just run all of the validation rules as a single, just one pass, because now you're not allowed any side effects now that all the hooks have settled down, and we can just validate anything that has changed. Which could be anything from not nulls to formats of fields, or anything that you'd want to write as a validation rule. Ooh, someday we could talk, or not someday, maybe later we could talk about reactivity, reactive validation rules. But anyway, I'll run all of those, and assuming they pass, batch your inserts, updates, and Bob's your uncle. I haven't said that in a little while, but Bob's your uncle.
Okay, 2 questions on that. So one is, how do you make sure there are no cycles if you're allowing sort of these hooks to to update things and generate hooks. I mean, I could write code that creates a cycle. So how do you make sure that doesn't happen?
Yeah, kudos to Zach, who wrote this. We just keep track of the entities that we've ran hooks on before, right? So we do have a loop, but the first iteration of the loop is like, oh, I ran it on these 5 entities, put them in the like hooks has already ran, never run them again, and okay, go on to my next, discover any new entities, and if there are new entities, run that on the second iteration, but like just, keep putting things in the list of never run the hook on this author again for this EM flush anyway.
So I couldn't, if I were to create a rule where I had a hook on authors that updated books and then a hook on books that updated authors, it would not work because like the authors one would run and then the books would update, but then their hook to touch the authors wouldn't.
Yeah, like the author would not have a chance to respond to whatever the book had done.
Got it.
You're right. So both will run. The author will run, the book will run. But if for whatever reason your author wanted to see the latest changes, then no.
See that change and react to it, it couldn't. Got it. Okay, so that answers one question. The other question I had is, so you're talking about batching. When does that batch go out? Like, does it wait until I've done a user response, or it just waits for some amount of work? Or like, what tells the flush that, hey, I've got enough things to do an actual write over the wire?
You just have to, whenever you in your endpoint decide to call EM flush, that's when the SQL calls happen. So it's kind of up to you.
Got it. So it's explicit.
Yeah, it's an explicit call to TM flush. It's not like put on the event loop to do, I don't know, or something like that. But no, and typically we do a lot of GraphQL mutations, and it'll be get the input, load the entity, put the input into the entity, and then call EM flush, and then return the result or whatnot.
Got it. But you could, in some ways, you could start streaming that result back out and then put the flush in like an after request hook or something like that.
Yeah. Joist does not have any opinions on when you would start to start returning data to your users versus when you try and commit things to the database.
Do you have visibility into the request such that you can like catch if there is unflushed changes that are still there at the end of a request?
Off the top of my head, no. We do have some. So Joist tries to be, in general, a pretty unopinionated. Well, I mean, it has opinions, but in terms of your APIs, like it doesn't really care about whether you're using RPC, gRPC, or GraphQL, or Fastify, or Express, or all of those sort of things. So I think because of that, it doesn't really have any visibility into any of those. My one caveat is just like because we personally use GraphQL, we've built a fair amount of scaffolding and glue kind of, on top of Joist for living in a GraphQL world. But there's a pretty clear delineation between the core ORM that could work with anything, and then like our little, GraphQL polish that is pretty neat, but optional on top of it. So yeah, you for your musing of drilling into the request, yeah, it would be exercise to the reader, I guess.
Yeah. Well, so how do you have per request caching then if you don't have visibility into the request?
In the GraphQL server, you get a little hook of making a context, in GraphQL.
Okay, so it's outside of the ORM core.
Yeah, right. So when we boot up our GraphQL server, it's going to ask for, a new request came in, and it's like a Fastify request entity. And like, how do you want to turn this into a GraphQL context parameter for all of the resolvers to use and that sort of thing? And that's where we're like, oh, okay, this is a new request. Let's make a new entity manager. And we put it on the GraphQL context. Or, you could do, Fastify lets you put things onto their request too. So you could do, actually, we do that first. So we've got middleware that first sets like request.context. So because we do have some Fastify handlers that are not GraphQL. And so they also have access to the request context and hence the entity manager if they wanted to do anything. But then most of our stuff ends up being GraphQL mutations that then, uses that context parameter to get the entity manager out of the request context and do any loads or do any saves.
Got it. So you're basically, you insert middleware and that's what sets up the entity manager, caches for that instance of the entity manager. Go. So you could actually, in theory, at the end of your middleware request, wrapping around on the other side, say, are there unflushed changes? Maybe I need to throw an error or something like that.
No, yeah, actually, a system that I did, back in the Java days did do that. Like our middleware created whatever our version of unit of work was back in the day, and auto flushed or auto committed whatever it was. Surely it was Hibernate back in the day, but the middleware did it, right? And our middleware doesn't. And I guess I don't have a real good reason for why. But no, yeah, you're right. It could.
Nick, I feel like I've been talking a long time again. What's going on?
Y'all are going
Sorry,
deep.
I get excited about this stuff.
It's good.
No, I love it. Yeah, this is great. You're asking way deeper questions than I know as a casual ORM user that usually just yells at it, but bangs my head against the wall until it starts working.
Well, you haven't used Joist then.
I haven't yet. No. The last one was TypeORM, and that's why I have those opinions, I guess.
Yeah, I was talking to a mutual friend who was like, you can't really understand the ergonomics of an ORM until you just use it in hate or not, or hopefully non-hate. But
yes.
It's hard to know until you get into the guts of whatever you're building, and you're like, oh, this actually does or does not suck.
So I guess to take it up a little higher level, as an ORM creator and just like a user of them too, what are some arguments against ORMs that you've commonly heard?
Yeah, sure. I think and I'm going to insert my bias into these answers, obviously, because I'm kind of an ORM apologist. But I can think of two things. One is that, and actually a different mutual friend, but we were talking about this the other week, is if you go way back in time, there's the paper from the guy, ORMs of their Vietnam of computer science. I forget his name, which was, made the rounds pre-Hacker News, and his actually, it's been so long, I forget the assertions of his paper, but was one of the first ORM pushback things back in the day. And my recollection at the time, and I should go read it, but was that if you go back to circa 2000, 2005, which is where both was maybe peak ORMs, but also peak ORM hate and kind of pushback. What I saw, the people who hated ORMs the most, and again, this is where I'm going to read my bias into it as kind of an ORM apologist, was ORMs that would try to work with a database schema that just fundamentally was not great, right? So, circa 2000, whatever, typically you're doing Java enterprise stuff in the back office of an insurance company that has a schema designed in 1970 or something like this. And you're like, wow, this schema has fields that are 4 characters long and all constants or something like this, which that in and of itself is not terrible. But ORMs there in the mid 90s and into the 2000s, tried to make their pitch of taking generally bad, I don't want to say bad, legacy, let's use legacy, relational schemas, and then crafting them into this beautiful object model that was genuinely different from whatever the database schema was, and patch over the sins of the past and these sort of things. And I think that's where that's just hard and difficult. And I don't, that's where you get a lot of this mismatch of the whole ORM versus relational mismatch. That's where all of this comes from, right? And I assert that if you don't try to do that, if you just make sure you join companies and jobs where you get a greenfield database schema, disclaimer, that you can cheat, and I assert that object relational mismatch goes away, because if you've got a nice schema and you just treat your tables as entities or even as a little graph, right? Actually, if a lot of what if Joist thinks in terms of graphs, right? It thinks of this entity points to this other entity. And granted, in the database, nodes are not explicit entities. It's not a true graph where you can go to a node and put attributes, you can't go to an edge and put attributes on an edge, on a foreign key. But otherwise, you really can think of the entities in your database as a graph. And at that, to me, it's just kind of this, if you squint and you look at a relational database, you can squint and see a graph, or you can look at a graph and squint and see a relational database. And look at an ORM and squint and see either of those. So as long as you're doing a one-to-one mapping, as long as you're doing a one-to-one mapping between those domains, I think the object relational mismatch doesn't exist. Maybe that's a strong statement, but at least in the way that annoyed so many people back in the day. And so that's one of my big main assertions as an ORM apologist is don't try to do that. Don't try to do all of the crazy stuff that they did circa 2000s of crafting your database schema to be something better and different.
One of the big arguments that I have seen and been on both sides of in the past was ORMs make it really easy to write non-performant SQL.
Yep.
And I cannot tell you how many N+1 loops I cleaned up back in the day. However, it seems as though you may have solved that with Joist.
Right.
So that is a big argument in favor, actually. I mean, and one of the things when I saw what you were doing with data loader and Joist, to be honest, I looked up Joist this morning in preparation for this episode.
Yeah.
But I saw that and I was like, whoa, they solved that problem. That's amazing.
Yeah.
Like, that's really, really good. I do think there is a question around. So one of the things that ORMs do is they push you to kind of make some simplifying assumptions about structure of tables. And one of the examples is the default easy way to do it is every table has a single ID that it's a sequence or incrementing number or something like that. And I have seen the argument, and I don't know how I feel about it, but I'm curious your take, that those basically allow you to get away from really deeply thinking about how your data naturally should be structured. Now, my argument is most of the people writing these database migrations are not data scientists or data engineers, and those simplifying assumptions on average lead to better data or better data structures than when somebody's trying to do every custom one. But I'm kind of curious what you've seen in that domain.
Yeah, I mean, again, maybe this is just my bias or my background talking, but I'm just so bought into the concept of entities, right? Like thinking about your domain model in terms of authors and books and book reviews and claims or whatever domain that you're interested in is, figuring out the logical, identities of the entities involved. That's just like so much how I think that, of course, I'm going to just have tables with ID primary keys that match my entities and that sort of thing. So I guess, and maybe I guide myself to be working in jobs that do that. Like I'm just building another web backend in, my version of Rails or whatever, that I think it works out really well. For sure, I'm sure there are, niche use cases out there of, I can think of, I do so much OLTP, but like the OLAPs of the world, which are all metrics and those sort of things. Like, I can see that, when you really start caring about storing data in columns and columnar databases and all of these, well, although even then, maybe you could represent those as entities. But yeah, I think I could buy that for certain super optimized niche cases. But like I would assert the benefit of the doubt is on that it's probably an entity, and onus would be on the other side to prove why it's not, and they need some sort of esoteric way of storing it. But that the other thing is that if you've got that rationale, then go for it, right? It's not like you have to use an ORM for everything, which was going to be my other point. The other thing that I hear an often criticism of ORMs, kind of back to your queries, is that ORMs almost always have query builders, and like once you start to get to a certain esoteric level of like a query builder that does like aggregates and group bys and inner queries and all of these other sort of things, like is it really that much simpler than writing SQL? And I agree it's not, right? So like once you hit a complexity of a SQL query that is like basically doing group bys and aggregates, I personally am not interested in writing a query builder to represent that, especially in a type safe way, except for the I'm going to say it wrong, but the Keisli guys, Keisli, however you say that, they've done great. So like go use that. Like if you've got a sufficiently complex query that needs all of these sort of things, like get as low to the metal in terms of SQL as you can. But like, if I look at our, the app that we've got in production, probably 90% of our queries and mutations don't need that and can go through the ORM for like super for free data access. And that last 10%, like, yeah, don't treat an ORM like the hammer that you have to do everything for. For that last 10% where you need the escape hatch to connects or Keisli or even just a raw SQL string, like that's fine. Take it if you need it. I think a lot of the anti-ORM people like see those use cases and now mean like, well, I can't use the ORM for the other 90% that it's just like select star from books or ideas, whatever, right?
Yeah, I think that's a big touchy point for me too, is when I could do this in SQL and I know how to do it there, but now I have to learn this seemingly esoteric way of doing the exact same thing.
Right.
That kind of turns me off from it.
The thing that I love about ORMs, and was one of the reasons I was advocating ORMs in a previous place that was somewhat anti-ORM, is the standardization of life cycles and validation.
Yes.
Because when you go to raw SQL or a raw query builder or something like that, there's no obvious place to put that validation in a way that no matter how this thing is being updated, no matter what's going on, we're going to make sure that the things that need to be true or should be true are true.
Yeah, your business invariance, 100%.
Exactly. And so what an ORM does is it provides a standardized way of representing and talking about and writing invariants that don't live in the database.
100%.
And that's incredibly valuable.
Yeah, I agree. I've obviously I've heard a lot of the feedback and assertions that, the subset of the community or a set of the community that likes to use raw SQL. I go to the same thing. Like, where do you validate that your author title is what you want it to be every time you touch an author? And I don't know. Yeah, I'd miss it.
Is there anything that we haven't talked about that you would like to share with folks listening to this episode, whether it's about Joist or ORMs in general?
Well, yeah, actually, I was thinking that the one thing that we haven't talked about too much, and we can try and keep it short because it could get, well, I don't know if it could get long, but Joist's concept of reactivity, basically. So like a lot of what we've talked about in Joist so far is, it's cool, but not necessarily novel per se. I guess data loader baked in all the way is probably novel.
I found it novel.
Yeah.
The data loader baked in all the way. That's great. I love it.
The type marking the collections as typed or not was novel. Actually, Micro, I believe, has a form of doing that now, which is great. I'm trying to think if I had done a PR to do a version of that in Micro, but I was chatting with the Micro and I took a lot of stuff from Micro, and he's like, I'm going to take the type hints from Joist and put them in it, which was, cross-pollination was great. But I believe that the kind of the last sort of novel thing that Joist has is the concept of reactive validation rules and reactive derived fields. So what these are is, so a lot of lifecycle hooks and validation rules by default, like only run if you're touching the entity itself, right? Let's take an author, and you've got some business rule that the first name has to be this or that, right? But what if you've got a business rule on an author that depends on like entities that it touches, right? Like I can only have 10 books, or none of my books can be published until I'm published or until I'm over the age of 18 or something like this. And so Joist has a way of defining both validation rules and then also derived fields in the database. The quickest one that comes to mind is like author number of books, right? Like let's say you've got an author search, you want to search about the authors, and one of the things you want to search on is number of books is greater than 10 or greater than 100. And you can do that by doing the join into the books and then doing the sum and aggregate and all of that. But a lot of times with these dashboard pages, it's great to just have an int column, right? I just want an int column in the database.
Yeah, you have a counter cache, basically. That's like caching the count as it...
Right, exactly. And it makes it super easy. And so let's say that we want to do these. So in Joist, you can define one of these, like I'm going to define a number of books. And we take those populate hints that used to tell us like the subgraph of entities to populate so I can get data to them. We take that same concept and we put it into our number of books declaration and say like populate this subgraph of the author in the books so I can count them and return 10. And that's all you do. And you're like, okay, that's great, but what does that get me? What that gets you is that Joist has the capability to reverse that load hint and now find any place that would basically invalidate that number and have it walk back.
You have a book created. Let me go back and load this and update it. Yeah, I love that.
Whenever a book is created, whenever a book is deleted, it also, like in this little reactive hint, you can say like maybe you only want to count the books that are published or something like this, some attribute of the book. And so then if you go back to the book and that only when that attribute changes, like the book moves from published or whatnot, it's like, oh, I know that the author derived field, or it could be a validation rule, depends on this field changing. So I will go find my author, even though he's not loaded into memory yet. I will go load him into memory and tell him to run as part of the EM flush. Another big, win for the EM flushes is like if you were just doing...
It will auto-save these sort of derived entities. Yeah, that's really cool.
Yeah, right. Like even though you've only loaded the book and you've only touched the book, you'll get into the flush and it'll be like, oh, I need to do these other 20 things.
That's beautiful.
And load them up and tell them to recalc or revalidate. And that is slick.
Well, and
it's slick.
That is because this sort of, that allows you to do something we've gotten very used to in the front end world, or at least in like Vue and other things, where you're basically creating these declarative interfaces where you're like, these are the things that must be true.
Yes.
Go and make it so. I don't want to have to worry about them. But doing that at the data layer is not something that I've seen done very often.
No. Yeah, the only thing that I can think of that's somewhat similar is like the super big data guys, and you get into like materialize IO. They'll sit on top of Kafka queues and watch for, or the other place is if Postgre ever gets like fully reactive views, you can declare a materialized view, but the materialized view refreshes every 10 minutes or so. And there are certain places out there that are trying to get, materialized views that incrementally update when, they can tell whenever the components of the materialized view update and then do incremental updates, not because the full update would be expensive. And so materialized does it. And then like people have toyed around with doing it like at the Postgre. But no, other than that, like you just...
But this is at the application layer, right? This is where I'm used to because there are ways that you can do these like, triggers within your database and whatever. And I don't want to be mucking around with stored procedures in my database. I want application logic that I can test writing my unit tests and just make it happen. Okay. So what are the limitations on that? Can I bridge through entities? Can I say, okay, this entity depends on that entity, which depends on this following entity? Like how?
Yes.
I just, okay.
It just works.
Just yes. Okay.
Okay. Only because we do have one boundary case that came up just last week or maybe it was 2 weeks ago. We've got it written up where we mentioned that, so there's difference in Joist between the core database relations of yes, this is a foreign key. Yes, this is a many-to-many. Yes, this is a many-one, right? So you can string together these reactive things with the core database relations, and everything 100% works. You can also go through one of your derived relations where it's not quite in the database. It's not in the database. But you want to have, what would it be? Like number of books depends on, we've got an example of this. Number of books depends on, the book being public. And that in and of itself is a derived value. But if you put two of these in a row, we've got a bug there where we need to go fix, like going through and stacking these non-core database things. So like just being upfront honest, like we've got a known issue with that. But I think that's
a bug, not a core limitation.
It's a bug. The core model, the core mental model works for anything you can think of, asterisk that guy. But we'll get fixed here next hack day or something like that.
I'm excited to go and build some stuff with Joist now because I have been looking for a JavaScript or TypeScript ORM that got anywhere close to what I remember from ActiveRecord.
Yeah, me too. The other disclaimer that we should, we really like tagged IDs, and I don't know if this is tagged IDs are awesome, but so like usually your entities come out with like it's an int in the database, and then you expect the author.id to be a number. Ours are strings. And we need a flag, like we love that, like because you see, and we put every entity gets a little tag, like author gets abbreviated to A, and book gets abbreviated to B, and these sort of things. And so those will show up in your IDs, which actually we did selfishly because we were doing GraphQL, which wants strings IDs anyway. And so instead of every time we put an ID on the wire, we're like int to string, whatever. I played my Java hand there saying, take it back. Anyway, and so it was just so ergonomic for us to have the ID getters and setters take strings. And then we took that opportunity to sneak in prefixes, which once I'm super addicted to that now. Like, seeing an ID go by in the log and being like, oh, that's BR26. I know that's a book review, right? And it also keeps your IDs from accidentally switching, right? Like, oh, I got a response and I got an ID of 2, but then I put it back into the system. And it's technically a book ID, but I put it back into the system as a book review ID, right? Well, book review 2 technically worked, and so my foreign key didn't catch it. But if you tag your IDs, Joist will notice that the tag is wrong and will blow up at runtime. But I mentioned that just in terms of this is a tangent away from if you go play with it. I think most people do probably expect the IDs to be numbers, and we totally want to support that because it's a very valid way to use ORM, but just haven't gotten around to adding that config flag yet. So hopefully you don't mind ID strings, IDs that are strings. Or if you really don't like it, you can submit a pull request, which would be great to support the numbers.
So question, are they strings in the database level as well?
No.
Okay, got it. So you're basically, when you pull it out of you're using a sequential integer or something, but when you pull it out, you put the tag at the front of it, and that's how it's represented within Joist. Okay, got it.
Yeah, right. I mean, that would be weird to do. I agree, to do strings.
Well, that was my initial reaction. I was kind of like, wait,
yeah,
is he saying what I think he's saying? But no, it's okay. That's entirely at the Joist layer.
Yeah, we do support UIDs, string columns. If you want to use UIDs as primary keys, we had a user come by and request that, so we snuck that one in. But
and those are also tagged in the Joist layer.
You can choose. You can choose to tag your UID, or you can choose not to. And I guess I don't think we give you that choice with just the regular numbers. We definitely don't give you the choice to use a number. But I guess, why not let you use technically to string with an untagged number in it? I
agree that Joist is awesome. I saw you present about it at Nebraska JS, and I'm excited to have an excuse to get away from TypeORM or to explore more of what's out there.
Yeah, for sure.
I don't have the same history with ActiveRecord or Rails or anything like that. So but it's super interesting how much thought goes into these, and it really seems like you're doing really well with the ideas in Joist. So I'm excited about it.
Yeah, good. Yeah, go for sure. Kick the tires. Let us know.
Yeah.
We've got a little link to Slack that I think probably works. There for a while it did not work, so let me know if that doesn't work.
Will do.
Or file an issue or all that. Let me know how it goes.
Definitely. And we'll have links to all this in the show notes. And Stephen, thank you so much for joining us this week. I learned a lot, and I learned that there's a lot that I don't know as well.
Oh, no, thanks for the invite. I just, had a ton of fun. Thought it went really well. Kudos for driving the agenda really well with great questions. And I had a lot of fun.
All right. Well, let us know what you think.
This was delightful. Yeah. Thank you for putting up with my interest in diving down into weird niches.
No, it's great.
Yeah, it was a fun conversation. All right. We will see you next time.
All right. That is JS Party for this week. Thanks for hanging with us. Next up on the pod, KBall, Nick, and myself partake in a grab bag of goodness. We're explaining class variance authority like we're 5, discussing KBall's new stack, Bun's new bundler, and much more. Subscribe now so you don't miss it. Head to jsparty.fm for all the ways. Special thanks once again to our partners Fastly, Fly, and TypeSense for helping us bring you awesome pods each and every week. And to Breakmaster Cylinder for keeping our beats fresh and banging.
Bears beats Battlestar Galactica.
That's all for now. We'll party with you again next week.